Lesson 8.5. Today's lesson is working with quadratic equations and factoring a special type that's called the difference of squares. Our essential question says, how do you factor a difference of squares? And our vocab word also says difference of squares. Squares means perfect squares. So if we have two perfect squares that are being subtracted from each other, that's called a difference of squares. Because subtraction is what the word difference indicates. So the difference of squares. To factor into two binomials, what you need to think about is what each of these terms is a perfect square for. So for example, a squared represents a times a, and then negative b squared would represent positive b times negative b. So, factoring my difference of squares, a squared minus b squared, gives me one binomial, a plus b, and then the other, a minus b. And I'll show you how that works if I FOIL this. A times a is a squared. My outside product, a times negative b, would be negative ab. Remember to write your variables in alphabetical order if you have two of them. My inside product, b times a, would be ab. And then my last terms, positive b times negative b, would be negative b squared. So what you should notice is that the terms, the outside and inside terms, are opposite each other, so they actually cancel each other out. Negative ab plus ab would be 0, so I'm just left with a squared minus b squared, my difference of squares. Okay, so let's try this out. The first one to factor is x squared minus 25. So what you're probably noticing is that when we've got two terms in our quadratic, instead of three like we've typically been factoring, the term that's missing is the middle term. So to factor this difference of squares, x squared is x times x. So I start each binomial with x. And then I'm moving to my last term, which is negative 25. So remember our combinations we would typically say could be negative 25 times 1, negative 1 times 25, or negative 5 times 5. Since there is no middle term, this is a difference of squares, it's not a trinomial that we're factoring, the 25 and 1 would not work. They would not work. So the one that has to work is the negative 5 and positive 5 because the middle term has got to cancel out. So my outside and inside products, I would get negative 5x and then positive 5x, which are opposites. If I add them together, I get 0. They cancel each other out. So my solution is just x minus 5 times x plus 5. My next problem then, c squared would be c times c. Negative 81. 81 is a perfect square for 9. So one of my binomials gets plus 9 and the other minus 9. c squared minus 81 plus 9c minus 9c. Add those together and you get 0 for your middle term. So c plus 9 times c minus 9 is how you factor. Now our binomials are going to be a little bit more complicated on these next problems. We're still working with perfect squares though. So difference of squares, 4b squared. We do not want to use 4b times b. We need 2b times 2b because there is no middle term here. No middle term. We've got a first term and a last term. So our binomials have to look alike, except one gets a plus and one gets a minus. Move over to my negative 121, and that's positive 11 times negative 11. Again, if you FOIL it, 4b squared minus 121, and you can see that these would cancel. Positive 22b and negative 22b. They're opposites. Next one, 16h squared. 16h squared is a perfect square for 4h, so 4h times 4h. 9g squared is a perfect square for 3g, so 3g and negative 3g. When I multiply these, if I FOILed it, 16h squared minus 9g squared, 3g times 4h, we would write as 12gh. And then 4h times negative 3g would be negative 12gh. Opposites again, cancel each other out. So here are our binomials for these two difference of squares problems. Now on our next two slides, you notice that we have the equal sign with the 0. So that means that we're going to have to do the zero product property after we factor. So y squared is y times y, negative 100, positive 10 times negative 10, and then do that extra step with the zero product property where you set each binomial equal to 0, and then you solve it. Some of you can do these in your head, and others need to write it out. So I'm just going to write it out for each one. So I'm just isolating the y, solving to get the y by itself. On the more basic problems, like this one, I don't mind if you do this in your head. I do want to see the factors though. I want to see this step right here where you factor the problem. I don't want you to solve the entire thing in your head. So I want to see your factors, and then if you can do the zero product property in your head, that's fine. What happens is, as we move into more complicated problems, if you try to do too many of those steps in your head, you sometimes end up getting them confused. So it's not a bad thing to write it out. 81g squared is a perfect square for 9g, so 9g times 9g. 4h squared, I need one positive, one negative. 4h squared would be 2h times 2h. Now on this problem, with multiple variables, I'm going to solve for the one on the left. So I'm going to solve for g, because typically we solve for x, and our variables are usually x and y. So I'm just going to solve for g on both of these. So that means subtracting 2h on both sides. So this isn't an easy problem by any means. And then I would have to divide by 9. Divide by 9. So my solution would be g equals negative 2h divided by 9. That's my first value. And then the second one, if I add 2h, so 9g equals 2h, and then divide by 9, g equals 2h divided by 9. So remember that I said I like to see the factoring step. On problems that are more complicated, where you have multiple variables or coefficients in front of the variables, it's probably a really good idea to write out your zero product property. So writing out this part right here instead of trying to solve it all in your head, it's a great idea if you have more than one variable or if you have coefficient numbers in front of your variable, okay? So don't be too stuck on trying to do everything too quickly. Okay, our last page of notes. 16y squared, it's a perfect square for 4y, so 4y times 4y, and then negative 25 would be positive 5 times negative 5 equals 0, so the zero product property, set each binomial equal to 0, because 0 times something equals 0. So one of these binomials, to get an answer of 0 over here, one of the binomials has to be equal to 0. So we solve them both. Subtract 5, and then divide by 4. So y equals negative 5 fourths for my first one. My second one, I would add 5. So 4y equals 5, and then divide by 4. So y equals 5 fourths for my second binomial. Our last problem, 9x squared is a perfect square for 3x times 3x, and 49y squared is a perfect square for 7y. So plus 7y and minus 7y. Now do the zero product property to finish. So set each of your binomials equal to 0 and solve them to get the x by itself. So I would need to subtract 7y on this one. And then I would divide by my 3. So x equals negative 7y divided by 3. And then on the other one, I would add the 7y instead. And then divide by 3. So x equals 7y divided by 3. So they do end up looking similar. They have opposite signs. So it's okay with me if you want to show your work solving one of them, like this, and then the other one would just have the opposite sign. That would be okay. You should be able to write your summary now. And your homework today is a worksheet.